Good afternoon to everyone on the East Coast. Good morning to everyone over on the West Coast. My name is Katie. I'm with the NOAA Central Library, and I will be your seminar host today. You are an attendee, so you are muted. If you need to ask a question or you have a technical issue, please place those questions or technical issues in the chat or the question panel, and we will get to all questions at the end of the seminar. If there is a technical issue, I would try logging off and logging back into GoToWebinar. That seems to fix most problems with audio or visual issues. With that, I want to remind everyone we are recording this seminar and it will be up on the library's YouTube channel after this session. Let's get to the good stuff. Today, we are very excited to have two folks from NOAA's Weather Service talking about the 2020 fire weather review, the current role of NOAA and the National Weather Service, including the Incident Meteorologist program. Today, we have Kari Fleegel, sorry, Kari, Kari Fleegel, who is the meteorologist with NOAA's Weather Service in Aberdeen, South Dakota. She entered the Incident Meteorologist program in 2002 and has since been on over 20 deployments to wildfires, oil spills, as well as large national events across the country. They both have had the opportunity to assist the Australian Bureau of Meteorology with on-site support during a couple of their larger fire seasons. And we also have with us Patrick Gilchrist as a warning coordination meteorologist for the Weather Service in Glasgow, Montana. And he has served as an incident meteorologist since 2006, supporting 25 large wildfires in the Western US. And they both have had the opportunity to assist Australia. I did say that already. So sorry for repeating myself, everyone. But with that, I am more than excited to hear about what happened last year. I'm going to turn it over to Kari and Patrick.
Thank you. Like Katie said there, talking about introduction to the Incident Meteorology program, how NOAA supports wildfires, and a brief recap of the wildfire season last year. So according to the 2017 National Institute of Standards and Technology report, the annual cost of losses from wildfires is estimated to be between $71 billion and $350 billion. So yes, a huge range there, but it really depends on the fire season. For example, 2019, we did not have a lot of large wildfires in comparison to last year. So that's where the wide range comes in. So like the monetary cost of wildfires, NOAA's involvement in fires is also enormous. Here are just a few of the groups that actively work on modeling, detecting, and predicting fires and their impacts. So we have modelers and programmers, IT and satellite folks, forecasters, administrative and budget people, as well as communications. So NOAA Public Affairs and Weather Service Communication Office, but also hydrologists. And each group is critical in sharing NOAA's mission, which is the understanding and predicting, the sharing and conserving of resources, and the Weather Service mission of protecting lives and property.
And you know, something that is frequently, I guess, not thought about is that just because the fire's over doesn't mean that the impacts are over. And we find that, you know, even though the fire's over and can be over for the matter of years and years and years, we still have these burn scars out there. And burn scars present an especially dangerous situation if they're on a very steep area, and especially in like a basin that can collect a lot of water. And so the NOAA and the Weather Service support these burn scars by meteorologists and hydrologists in the offices continue to monitor those areas to look for heavy precipitation events that could promote runoff. What's very interesting is when the fire burns, you actually get this waxy substance as a byproduct of combustion that can form up, again, depending on the temperature of the fire, and it can form a crust or a layer within the soil that was actually very hydrophobic, and it insulates the ground from being able to absorb runoff, and that promotes massive amounts of runoff. And again, that's where you run into those debris flows and You see mudslides, that sort of thing, well after the fire has actually ended. So the Weather Service offices, hydrologists, continue to support those by keeping a close eye on that, working with emergency management, and to make sure that people are ready and that they know that they're in those prone areas, and to promote what action needs to be taken based on the best information available for those folks to make sure that they stay safe. So burn scars, again, are a big problem and can be problematic for years and years after the actual wildfire.
So there's a small group of us in the National Weather Service that do respond to these large wildfires. When we do respond, we bring what's called a all hazards meteorological support system. And that includes a laptop with a printer, a cell phone with 4G or some sort of hotspot capabilities, and weather equipment. We're called Incident Meteorologists. We do bring upper air kits and surface weather instrumentation as well. And in the picture on the upper right, you'll see a person holding a balloon. The balloon is filled with helium, and it's tied with a string to a parachute. And eventually in his right hand, you can see a weather instrument package. And in there, we have weather sensors that give us temperature and dew point. And we can also figure out the pressure, atmospheric pressure. And then as we track the balloon as it goes up into the sky, we can also figure out the wind speed and wind direction. And all this is super critical to figuring out what the weather's going to do, not only in the next 10, 15 minutes, but also we incorporate that with what other weather balloons that are sent up throughout the day at over 120 locations across the United States, and get a better picture of what's going on, and very helpful. So these weather balloons, they go and ascend to about 35,000 meters, or about almost 22 miles in the air before they pop, and then we lose the feed. But Patrick here will talk about a little bit more about the IMET, or Incident Meteorology program.
So thanks, Kari. The IMET program has been around for a long time. It actually harkens back to the first IMET deployment was in the state of California in about 1928. So this is not exactly something that's new to the Weather Service, although it has grown exponentially as we get closer to our day. You know, IMET deployments used to be a pretty rare occurrence for a long period of time, you know, through the 30s and 40s and 50s. But then when we started getting into the 70s, 80s, 90s, and then current time, we've seen just an exponential growth. So currently, the IMET program is made up of about 80 of us, 80 specially trained Weather Service meteorologists that are all volunteers. And I think that that's something that's important, is that there's nobody that has a requirement in their job to be an incident meteorologist. It's people step up for this sort of work and volunteer for this sort of work. And again, it's very important type of work, you know, to provide that on-scene decision support service where we provide information to the people who are making decisions, both tactical and long range, on what they're going to do to fight this fire. It's you know, very almost military-like in some regards. But we're out there, we're providing that information, we're feeding information to those decision makers and watching them make, you know, $1 million plus decisions based on the information that we're giving them. So it's a very fascinating side of meteorology, and I always say it's a very good experience to be able to live your forecast. You know, so often in weather offices, we write forecasts, we send them out, and it's a very goes out into cyberspace, goes out into the public, and it's you know, we don't get a lot of feedback on what that meant to somebody or what decisions were made based on that information. But out on a fire, you live it. You're seeing real time what people are doing based on what the weather forecast is and what the expected conditions are. So it's an incredibly rewarding, incredibly amazing experience. I think that I just can't speak enough about. But we do also cover more than just wildfire. I know Kari has gone out on oil spill, I believe in Michigan, right, to support response there. So we are considered all hazards. We do have the training to help out with a whole host of emergency situations, not limited to fire, but obviously with the nature of the program and the way it's come about, that we really are tailored towards fire in many regards, but we can support just about any kind of an incident that's out there. We are diverse in that we're spread out across the United States. You know, it's obviously, again, within the history of the program being wildfire and western. We are heavily weighted towards the western U.S., but we are spread out. As Kari mentioned, she's in Aberdeen, South Dakota. I'm in eastern Montana, which is also known as West Dakota. So we do travel and make up the distance to do those supports, but we are again scattered all across the United States. And here's our nice picture here from one of our last trainings where we actually had face-to-face trainings. It goes back a while. But we do have, again, specialized training. We do tend to meet on a third of us meet every year outside of COVID, where we get together and we really got to stay up on the latest technology. You know, I think everybody knows in science field, things change quickly. There's lots of new developments, lots of new models, lots of new information that's available and new ways to do business. And those meetings that we have, both virtual and in person, really do a good job in keeping us up to date on what the latest and greatest technology is and make sure that we're ready. So when we go out into the field, we can provide the maximum level of support and that it's consistent across all IMETs. You don't have one IMET that's here, one IMET that's there, that we are very uniform and the amount of response and the kind of response that you can expect to give. And so, like I said, a third of us meet every year in person outside of COVID, but we do also meet and do virtual trainings for those who aren't able to attend in person. And we actually just got done with everybody on a week-long, very intensive 8-hour-a-day training, and it was actually top-notch and pretty amazing. So my hat's off to the folks that did it, including Kari that set up that training. But we call it the Continuity of Excellence Exercise, the CEE. And again, very good experience and very excited to get going for this upcoming fire season.
So of course, 2020 gave us some challenges, one of them being COVID and not knowing everyone's individual comfort levels with that and the risks that COVID-19 brought. We definitely got a group together to figure out and plan some protocols, like what was best, and make sure people were comfortable going out during the fire year. We did have a few people decline, and that's totally, absolutely understandable. But one thing we did when we went on missions is we would write up reports about how it went, what the teams that we were working with were expecting from us, and each team is a little bit different. So when we go out on these missions, we work with incident management teams, and each team has different leadership. They may be federal, state, or local, and they all have different protocols when related to COVID-19. So we shared our lessons learned as the Incident Meteorology program, and I believe that really helped us stay safe last year. And because of the extra precautions, the typical illnesses that we get on these campsites, we just didn't get. We didn't see as many of them. One of them is we call camp crud. It's really an upper respiratory sort of illness, and it was nearly eliminated last year. So positives and negatives when it comes to that. Also, the incident meteorologists, I don't think we had any that contracted COVID during the season. So that was good as a result of their incidents. Right here we have a graph of how many deployments or how many missions we go on through the year. So we started January with very little, of course. There's a lot of snow on the ground. We don't have the heat. When you talk about fire, we talk about heat and dry fuels that really start things going with fire. And a lot of it starts in May, June, and July, and we have a peak in the middle towards the end of the summer. So through early August, we really did not have a lot of missions to go out on. And we were starting to think that it was going to be a similar situation to 2019, which is a very slow fire season. We had only 29 incident meteorologists on missions up until August 1st, and that was the 10th slowest on record. And our records go back to 1987. It definitely didn't stay that way though, as many of you remember. So we'll touch upon a couple of reasons why a little bit later. But one of those was the lack of a monsoon. In fact, some people said it was a no-show or a non-soon. So well below average precipitation fell over the southwestern US. In the summer, under intense solar heat, we typically have over Mexico and the southwestern US, we end up with a shift in winds that eventually brings up this area of high pressure and can bring in additional moisture that slowly moves from south to north as we move through the summer months. And that just did not happen. So typically July and August are some of the wettest times of the year for Arizona and New Mexico, and they were nearly bone dry. So a lot of very, very dry weather, a lot of record heat to contend with. As a result, you have dry fuels, dry branches, grasses, and trees, which are very prone to fire starts. So instead of the typical pattern that we see, it was basically a no-show. Monsoons typically set up from mid-June through the end of September for this area, but what they end up doing is bringing moisture slowly up from the south. But even before we get a lot of that humid air into the region, we can still have fire weather hazards associated with the monsoon. And that includes thunderstorms producing fire starts with lightning. We can have erratic winds from downburst thunderstorms and just strong winds as well, and heavy rain causing, like Patrick showed earlier, debris flows. So lots of hazards associated with the monsoon before a lot of the humidity picks up. One reason for this monsoon not showing up is we had low pressure and more rain in the northwest that kind of kept this other area farther to the south. So not much going on for the monsoon and not much of relief.
And of course, we had long-term drought concerns too that also were amplified by that lack of monsoon with the precipitation that it provides. If we go through this runs from July of 2019 through August of 2020. You can see that the drought really intensifies from the Four Corners region, Rocky Mountain, through the Great Basin in Northern California, and then into Western Oregon, if you watch this, how this proceeds. And of course, the later we get into this, the more impact that we see from that lack of a monsoon. The monsoon, not only provides humidity, but also provides some precipitation under that high pressure ridge. So without that, we really did not see conditions improving at all. In fact, what we saw was a deterioration as we went through the summer months. So we just kept setting that up for what we eventually saw with that late season craziness in the fire world. Was we just continued to see the deterioration, and that really set the stage, going forward for the potential for fire and to make those fuels, the trees, the grasses, really receptive to fire. And we did eventually start to see some starts, and this the first round that we really saw here is we saw some onshore flow, which is flow coming in off the Pacific Ocean. Had enough instability associated with it that we were able to develop showers and thunderstorms across Northern California and again Oregon. And we had an upper level system kind of drove this overall thing, the dynamics, and triggered those thunderstorms. We did get a fair amount of lightning. So our first lightning bust and our first real change in the overall fire season was seen the 5th through the 6th, where we saw our first rounds of large fire growth and really started to realize some of that potential that the drought conditions had brought. If we go to the next slide, we also saw the second round coming middle of August, 16th through the 18th. We had record heat during this time, so we had dry thunderstorms, which weren't producing much in the way of precipitation, but were producing gusty outflow winds. And again, that's a really bad combination for firefighters, because you have lightning that strikes down, starts a fire, and then you don't see much in the way of precipitation to help put the fire out or raise the humidity so that the fuels aren't as receptive to fire. But what we do have is gusty outflow winds from that dry thunderstorm, and that pushes the fires, and you start to see rapid fire growth right after the lightning strike. And again, during this time frame, we saw the the highest impacts. We saw hundreds of wildfires developing across Northern California, including the million-acre-plus August complex, which set all sorts of records. But you can see during this time, just a lot of lightning. Again, we know we were in a drought. We had very receptive fuel beds, and couple that with low relative humidity and record heat, and that really sets the stage for large fire growth, and where it's really problematic and very difficult to contain. So your initial attack, firefighters that are going out there are not going to probably have much luck, and did not have luck in this case, at containing the fires when they're small. So that allowed them to grow large and grow together and form like the August complex at 1 million acres. That's pretty staggering how large that is.
So smoke has definitely become more and more of a concern as we learn about wildfires. And here's an image, I believe from August 20th. And you can see all the fire starts on there, all the heat showing up, satellite depicted fire, all those red little dots. And then the gray and white is the smoke. We also have a few just regular afternoon summertime cumulus clouds in Nevada, but a lot of this is smoke. But it's become more of a concern. We're learning about health issues related to smoke, from burning eyes to runny noses, and it just really aggravates people with chronic heart and lung issues as well. Those small particles, microscopic particles, can really get into the lungs and cause some dangerous situations. One thing that is very good for that is those the N95 masks, and that's one thing that we promote through the National Weather Service and a few other agencies for safety concerns with all the smoke. But forecasting where the smoke is and where it will be over time has gotten a lot better. One thing that we use in the bottom right here is the HRRR model, which is the High Resolution Rapid Refresh Smoke Model. And it runs hourly, updates hourly, and goes out through at least 18 hours or potentially 48 hours in the future. So we can get a better idea of where that smoke may be, not only throughout the day, but maybe the next 2 days. And definitely a breakthrough for people who need to stay away from some of these areas in red where smoke's a little bit more dense and potentially dangerous. Another thing we're able to do is not only predict where smoke will be on a map, but also whether it may stay towards the ground or stay elevated in the sky and just covering up the sun a little bit, because it all makes a difference. One thing I wanted to tell you, by the end of August, the large fires, Patrick said we had those few lightning events, we had not a lot of rain and just continued drought conditions. So by the end of August, all the fires were from New Mexico all the way up through Oregon and in through Washington. Most of our incident meteorology missions, however, were across Northern California and into Oregon. So by this time, August 24th, we had 67 people out on fires. And you can see on the second map there, second graph, we have 29 people deployed on one day, and it was close to, on average, the peak of the season. Late August, early September is generally where we see more incident meteorologists out on fires, because that's when a lot of the larger fires are ongoing. So go ahead, Patrick.
Okay, so I'm going to talk a little bit about my first dispatch. As you saw up until this point, it was very, very quiet in the IMET world. We knew there was potential, but we just weren't seeing a lot of fires prior to those lightning busts in August. So at this point, I'm kind of thinking, well, maybe I won't get out this season. But by and large, following the lightning busts, I did get a phone call from our dispatcher, Larry Van Bussum, and accepted to be able to drive to the Cameron Peak fire. This was in Colorado, just west of Fort Collins in the mountains. Very, very beautiful area, an area that I had never actually been before as an IMET, so I was very grateful for that. I'm always excited for new adventures. But if you hit play on that, you can see things turned very quickly. So when I first arrived on the scene, it was very quiet, like eerily quiet. There just wasn't much in the way of fire behavior at all. We had just gotten some thunderstorm rains on it, so it kind of had gotten up, it had made some pushes, and then it got rained on and it went to bed. And you go up there and you think to yourself, well, this fire is out, you know, why am I here? You know, you can be lulled into some complacency there, but we knew that there was huge potential just based on how dry everything was. We had a lot of bug kill up in this neck of the woods. And so we knew there was a lot of potential. And what things were threatened by this specific fire was the Rocky Mountain National Park was threatened by this, the north end of it. The CSU has a mountain campus that was very much under the gun from the path of this fire spread. Had a lot of small towns, a lot of infrastructure in there, a lot of cabins, a lot of retirement homes, again, all under threat. And again, you know, it was very, like I said, tricky because it was very quiet, and then all of a sudden it wasn't quiet. We had now dried out the effects of that rainfall, and our grasses and our trees were now receptive to fire. And over the course of about 3 days, we burned about 80,000 acres of timber. Now that is a pretty staggeringly large area. It's about twice the size of Washington, D.C., and this is wall-to-wall timber. So you can imagine the amount of heat that was going off on this. And if you click on that video again, sorry, this is a time-lapse video that the trainee that I had and I took of the fire, and you'll notice it looks very much like a thunderstorm. For those of you that have background in meteorology, it looks very thunderstormy, and that's because a lot of the same principles are in effect, the same thermodynamics are occurring. But this is the fire starting to take off. This is when it made one of its big runs. This is on the second day of that 80,000 acre burn. But you can see just an immense amount of energy being released by these fires. You know, it's pretty amazing at what these guys can do and what these fires do. And they get, like I said, every bit as tall as thunderstorms, and they actually have some of the same risks as a thunderstorm. They can develop lightning is possible when you start to see those pyrocumulus, the white cumulus forming on the top of a fire column. You got potential for rainfall, and if that rain happens to fall back into the column of air that's coming up, it can evaporate, form cold air, and which basically is the same principle as a dry thunderstorm, where it causes gusty, erratic winds or column collapse. And again, these situations are very dangerous to firefighters, and we were ahead of this pyrocumulus development that you see here, and we were radioing it in from our sight lines here to make sure that people knew that this was occurring and that they needed to be very much on this, remain safe. So. Something else that was very unique, and I guess about the my Cameron Peak dispatch, was that we did have, as far as I know, the only significant COVID outbreak in a fire camp that I'm aware of, and that made for some very unique aspects to this fire, where we were having, you know, we followed all the same protocols as everybody else, you know, masks, lots of hand washing, lots of sanitizer, that sort of thing. But we also ended up having to take it to the next step, as it were, as a result of these positive tests. And in fact, within, I would say, 5 hours of me showing up to the incident, as I was swapping out with another meteorologist, somebody came in and said, I need you to pick up your things, I need you to go to your vehicle, and I need you to hold up for a little bit, because they were worried that I had been exposed, because there was this exposure that had gone through camp. Somebody had came in off the lines and gone to a few places, and then turned out they were very sick. Luckily, I was not exposed to the point where I had to hold up or go home. I guess I wouldn't be going home, but I'd have to hold up in a hotel or a tent for 2 weeks. So luckily, I was cleared from that. But it shows you just how, you know, how serious the situation was. We ended up having testing protocols. I got the brain tickle a couple of times while I was out there, which was again, if anybody's had that, they know what I'm talking about. But again, we still had this fire to focus on. So even though we're having to deal with COVID a little bit, we had this fire to focus on. And you can see on the right picture there, that is actually, his name is Corey Motice. We are actually working the same office here, but he was a IMET trainee on this fire. We were out taking observations on a dam, and you can see this is when the fire was just starting to get going, starting to pick up ahead of those big burn days. So again, pretty unique situation. It actually ended up becoming the largest fire in Colorado history. Those 80,000 acre burn day or 3 days that we saw added to this, but there were also several other big burn days beyond this, beyond Corey and I leaving this incident. And it went for the full length of the summer and well into the fall. Again, times when it should have been end of fire season, we just continued to see it drag on, and it became the largest in Colorado history. Actually, a little bit larger than the East Troublesome Fire, which was also in 2020. And we've got this map here that shows kind of the range of it. To the south, and there is Rocky Mountain National Park. Out on the plains here, we've got Loveland and Fort Collins out here on the east side, and you can see that some very interesting runs here, and you can kind of tell the wind direction associated with those runs. You can usually tell by the shape of the fire what direction the wind had been blowing, but you can see a lot of concern in this neck of the woods. There's a lot going on. There's a lot of people, a lot of infrastructure, and final tally was about $132 million that was spent on this incident. And just a little bit of comic relief here. We have these weather stations that we can get put out on the incident that can support us, called a RAWS, Remote Automated Weather Station, and we can order them up from an outfit associated with NIFC, National Interagency Fire Center in Boise. So we had these fire RAWS out here, and we kept getting one that just kept being dumped. And we'd go out there, we could see some paw prints or hoof prints out there, and we were getting a little bit frustrated. But then we initially thought it was an elk, but lo and behold, it was a bull moose that was wandering out around the fire area, and for some reason decided he wanted to rub against our fire station, our weather station, and kept knocking it over. Did some damage. We had to replace the color on the anemometer, but did provide a little bit of, like I said, relief in some ways. You know, when you kind of have these natural things going on amongst these high stress situations, you have these fun little things that are going on. Makes it interesting. So, Kari?
Yeah, so here's a satellite view of where we're at this time of September 8th, showing the results of a really strong cold front that moved all the way from pretty much all along the west coast from the northeast, and brought very dangerous fire conditions, low humidity, really strong winds to the area. So continued through the 9th of September. Fires were blowing up from the west as the winds were pushing all the smoke and fire to the east. And at this time, firefighter resources were starting to grow really thin, because instead of just having a couple of fires, we're having several large incidents to look after. Here's a zoomed in view of like the Washington, Oregon area, and you can actually see not only smoke, but here's dust being blown off of Mount St. Helens and Mount Hood as well. So very strong winds coming out of the east, pushing stuff to the west. And this was also when the Lion's Head fire burned down part of Detroit, I believe, Oregon, on September 9th. So very, very dangerous. This is at the same time in California, the North Complex was starting to make a run. At this time, it was made up of the Claremont fire and the Bear fire, and just rapidly intensifying. This is just one of the many webcams that are used across the southwestern United States. They're critical in helping not only pinpoint where fires may be starting, but in this case, showing the fire behavior, just this very, very active, intense burning going on, all that very dark smoke. This isn't a thunderstorm. This is the actual fire cloud. This is a pyrocumulus, and it's indicating very strong winds at the surface. So very critical that we have these nice webcams to help us figure out what's going on there. But once again, very, very dangerous as well. I was sent out to the North Complex towards the end of September. So this was after the big blow up, and it ended up being the 5th largest wildfire in California history at about 318,000 acres. So to put that in perspective, it's about 380 central parks about 1.5 the size of Dallas, Texas, or roughly the size of Phoenix. Just a very large area that burned very rapidly. So while my mission specifically was supporting CAL FIRE, which is the state agency for wildfire protection, and their efforts in the western side, we also had federal folks dealing with the eastern side of the fire as well. So they had an incident meteorologist over there, and I was on the west zone. So very large fire, lots of people involved, and fire suppression alone for this incident were nearly $179 million. So that's just fire suppression. That's not rebuilding of homes or anything like that. So very, very dangerous fire. Here's just a couple of pictures that I was able to get for firing operations near the penstocks and PG&E powerhouse, and just a fire engine there with fire in the background, just protecting not only the powerhouse, but I believe a home as well. So taking a larger view of this area, just perspective, this is an area that's had much tragedy in the last few years. On the southwest side, you have the Oroville Lake. So some of you might remember the Oroville Dam crisis back in 2017, where they had water flowing out of that. And then in 2018, there was the large campfire, which ended up burning down much of the town of Paradise here on the western side. So a lot of destruction and damage. My part of the fire that I was forecasting for was anything southwest of that line there. So a lot of infrastructure. If there were stronger winds that came in from the northeast, the potential for the fire to move into Oroville, or eventually potential to move towards Paradise again, was high. So it's good to have weather folks there to get an idea of their confidence in winds, wind direction, wind speed, also humidity, and give a better idea for strategic planning for days or even minutes ahead of time, keep firefighters safe. So like I mentioned earlier, the North Complex ended up being the 5th largest in California history, but really about 80% of the largest fires since 1932 have occurred in the last 20 years. So impressive statistics. And it's not just one reason. As many of you know, there's multiple reasons. Climate change, we have longer fire seasons and warmer falls. Forest management practices have changed over the years. You know, looking back, maybe 50, 100 years ago, the idea was if there was a fire, let's stop it. At this point, we know there is such a thing as smart fire. We want to make sure to get the fuels, the dangerous fuels, under control and stuff like that. Also, we are encroaching into the forested areas and starting a lot of the fires ourselves, especially in the spring and late fall. So lots of changes have occurred since the 1930s to make all this happen. So with Patrick, I'll switch it to you again.
So after returning home from fire in Colorado, I decided, that I was probably going to be needed again. Things were getting tapped pretty good, resource-wise for the fire world was getting very stretched thin. We were at planning level 5, which is basically all hands on deck. So I kind of figured I'd be needed again, and that actually caused me to rethink some of my own preferences when it came to the COVID world. As Kari mentioned before, that they said that you didn't have to fly, you didn't have to, take an assignment. I was, of course, like everybody, very concerned about COVID, but given the national emergency that was going on, I did agree to take the Lion's Head Fire in Oregon, and the best way for me to get there was to fly. So I did adapt as needed and try to be as careful as I possibly could, and it seemed to have worked for mitigation. But I was on the Lion's Head Fire, and during that big east wind event, this fire very much reacted, burned up and over the Cascade Mountains from east to west. That is a downslope wind on the west side for this area, and again, very notable, very dangerous wind. If you talk to anybody out in Oregon and you talk of an east wind, that's going to very much perk their ears up. But this fire also had its own challenges, even though it had made most of its big runs before I got there, and we were way late in the season, and we're kind of still working on containment, but starting to think of mopping it up and getting it to a point where we could transition. It did have two very distinct climate regimes, and that made for a very interesting forecast challenge. On the east side of the Cascades was very semi-arid, a lot of grass, ponderosa pine, it quickly turned into ponderosa pine and then grass and shrubs and juniper, that sort of thing. Very much a drier climate, warmer. Then on the east side, it was very wet, a lot more dense timber stands, just a very night and day difference. So that provided a little bit of a forecast challenge there, was making sure I provided for the warmer, drier climate that was on the east side versus the wetter, a little bit cooler climate on the east side. And actually, when we were getting towards the end of this thing, we get precipitation. We would get precipitation on the west side, on the upslope side of the Cascades there. But we kept getting downsloped out on this east side. And we actually, up in this neck of the woods here, the far northeast section of the fire, we kept having a little bit of problem. Every day it would just kind of wake up and cause a little bit of trouble for us. So that was interesting how that climate really factored into really how we were fighting this fire and where the problem areas were. So a couple of quick pictures. The one on the left, showed just how smoky things got on some of the days when we would get those more stable conditions. The smoke really was a problematic area, especially with the amount of driving that we had to do given the size of this fire. And the one on the right is from Detroit. It's always, incredibly sad and moving to see when fires impact these small towns like this. And the nature that it does it is very strange. It'll pick one house and burn it to the ground, and then the house next to it will be fine, and then the next house will have been burned down. And it's just seemingly random the way that fire traverses through communities like this. But again, very humbling, very, very sad situation to see just the amount of devastation with the town of Detroit that largely was burned to the ground. And this was when they were actually had these engines out, I think, trying to shelter them on pavement and away from things. But you can see it still got caught and unfortunately still burned up this engine that we have here. Just a nice shot, I guess. I had to work on this RAWS. We had some 80-mile-an-hour winds earlier in the incident that actually had bent that RAWS station over slightly. It didn't knock it over, but it had bent it, and we noticed the winds were acting up a little bit strange. So you can see remnants of an old fire up in where this RAWS went, and again, that's kind of a safe place for these weather stations, so they don't get have less chance of getting burned up again. Or if the fire comes through, it'll be a little bit lower intensity with the brush around. But they had to do a little bit of work, and one of the people I was talking to was on a saw crew, took this picture of me, and turned out very nice with Mount Jefferson in the background. Again, a very beautiful area with the Cascades there. If we go to the
Okay, so fire season continues. So in October, I was sent to the Mullen Fire. This is in Wyoming. It ended up being likely the largest fire, well, the largest fire on record for the Medicine Bow National Forest, and was probably the largest single fire in Wyoming history. You may have heard of the Yellowstone National Forest fires back in 1988. Well, that was several lightning start fires, whereas this one actually originated from one single point. So that's why I said it's probably the largest fire in Wyoming history. Patrick and I have been talking about, this was the largest fire and that was the largest fire. That's what 2020 was. It's very dramatic, I guess. Very significant large fire season. So over 80 buildings were destroyed, and lots of hazards to go along with that. There were concerns that the fire was going to either creep north or potentially burn into some of the fires that were in Colorado to the south. So luckily, while I was there, we ended up with, on average, about 2 inches of snow that occurred on October 11th. And you would think, okay, great, everyone can go home. We got some snow. But that's just not the case. In fact, firefighters don't really like snow. It's cold, it causes very slippery conditions, and you still have fires that are burning in stumps, trees, and potentially even underground. So not the best overall conditions. So uncomfortable for everybody. One thing we do when we're on these fires is we actually support air operations as well. Most of these large fires have a large group of aviation resources. Here on the Mullen fire, we had buckets being we had tankers that could scoop up water from the lake. So this one here on the left is actually scooping water. We had helicopters that were able to pick up water from tiny ponds. In fact, the pond was very, very small. And here on the right is actually just a large drone, or a UAS, the unmanned aircraft system. So the unmanned aircraft system, or the drone, had about 3 or 4 people supporting them, and they would end up going up out at night or late in the afternoon. The drone would fly up to about 15,000 feet and be up there for 8 to 10 hours at a time. And what it did was we would tell it where to go, and it would detect hotspots with its infrared camera. So very critical information in real time that could support firefighter decision making. But one thing that they can't fly in is strong winds. And if you know Wyoming, they're very well known for winds. So after about my 4th day on the incident, there was really no more flying of anything. And most of the aircraft, and especially the drone, got demobbed or sent back home. Go ahead, Patrick.
So, where did we end up standing with 2020 when it was over? You can see we did burn over 10 million acres as a whole, which is actually bigger than the state of Maryland, which is around 8 million acres. So we burned a very large chunk of the United States. We burned about 3.5 times more acres burned than in 2020 than the average year. So we were, way up on the amount of acreage burned. But what's interesting about this is if you look at the top statistic here, 58,258 fires, the 10-year average is 62,000 fires. So while we had less number of fires, those fires were very large in nature. So what fires did get established and were very difficult to control and grew very large. So, kind of an interesting year. We're above average on acreage burned, but below average on number of fires. But it shows you just how large they got. So 188 missions ended up being our 4th busiest year on record. So what went from, we're well out below normal, just on the outside of the standard deviation here through the early part of August, ended up being our 4th busiest on record. And you can see that the chart on the bottom with qualified IMETs on assignment per day, you can see we ended up crossing over in September, and we set a new record all the way out into I'm guessing beyond October. I have a little trouble seeing that, but we set the new record for that late season for fire in late season. Again, very unique. I'm not sure if this is the pattern that we can expect going forward. This is just the one time that we've seen something like this, but certainly interesting and certainly a strange experience to be out on fires in October, even into November for some of the IMETs. Just a very unique one. We typically consider, August, September, kind of our core fire season for IMET dispatches. This ended up pushing it way out into October, and we stayed busy, and certainly ended up being quite a long fire season for us IMETs. And a nice shout out here. We've got some photos here. Kari and I are the ones who get to present here, but there were a lot of IMETs out there. Like I said, 80 or so that put in a lot of hours, a lot of time, traveled long distances to, again, support these important fire operations to make sure that people again had the best information possible for making decisions on how to fight those fires. So big shout out to the IMET Corps.
And especially not only the IMETs, but the ones that are back in the offices filling shifts, and the folks that are helping us fill out the paperwork as well, because it's a lot of work. So we ended up with 67 incident meteorologists on missions in 2020, with the average response time, so the time to get to an incident, being about 13 hours. So over 700 staff, whether it's at Weather Service offices, regional or national offices, really supported the entire program, and with logistics, admin, and, you know, like I said, covering shifts. So a lot of work that has gone into this. I'll end up here with a little bit more information if you're interested in following us about where we may be sent over the next year, or want to know more about different fires. We're going to be doing a recap of several of the large fires during the 2020 season on our social media pages. So I have the links here for our Twitter and Facebook pages. And if you're interested in fire weather at all, just weather.gov/fire. And with that, if there are any further questions that maybe we don't get to at the end here, we do have our email addresses. So patrick.gilchrist@noaa.gov or kari.fleegel@noaa.gov. So with that, I'd like to roll with any questions.
Great. Thank you so much, Kari and Patrick. That was super informative. And my first question, before others get their questions in, my first question is, do you want to predict what this season is going to be like?
It's always tricky this early out, and I don't have a good feeling. Now, the Climate Prediction Center did put out its latest outlooks, and the 3-month core for the summer, July, August, September, did, interestingly enough, have a bullseye for cooler than normal temperatures over the western US, which is, again, not something that I can recall in recent memory having those kind of favors, or I guess more favored climate and weather for that period of time. So that could provide a unique experience and make this fire season a little bit different. But also worth noting that it's also very much bullseyed for below normal precipitation and drought conditions across the Four Corners region. Again, did not see much in the way of improvement. You know, they got hit by a big snowstorm here, which should help a little bit, but they're still very much under the gun for some severe drought conditions. So I suspect, you know, we'll be back to it, I guess, sooner than later. Every time I think we're out, we're back in again. So, Kari, you got any thoughts?
Just that a lot of it ends up being specific smaller weather events that depict how the fires are going to react in the short term. You know, you have a couple of lightning events, or you have a really strong cold front that moves through, and you have those big fire days with explosive growth. So we'll see what happens.
Okay, thanks. We have a number of questions, and I'm going to start with those. Our first question is about the drone. You were saying that you guys use them for imaging, but is this something you also use for atmospherics?
Good question. So at this point, they're pretty new to the fire world and using them on fires. I'd say that most of our large fires don't have drones yet. But it's something that's growing in the program. Right now, we haven't used it specifically for many weather, much feedback for weather. I was able to get the wind speed and wind direction at that 15,000 foot level in reports, not exactly in real time, but it was still pretty interesting and helpful. But I definitely see them used more in the future.
Great, thank you. Our next question. Are detailed climatologies, normals, etc., useful in your real-time tracking of fires?
Yeah, it's more on planning. So it's planning not only for the next week, maybe 2 weeks, 3 weeks ahead of time. It's for the people who are trying to figure out where to staff folks, maybe set them aside or get ready for potential for a large incident. Maybe not in the day-to-day on boots on the ground. At that point, we're looking at like some of the remote automated weather stations that Patrick showed, and some of the Kestrel and other instrumentation that we're using to get actual surface conditions in real time, but definitely very important in the planning.
I think it also is useful in framing the weather that we have in the short term too. I know that, you know, being on that fire in Oregon, we saw 80 degrees lasting for weeks and weeks and weeks, it felt like. And finally, we realized that 80-degree mark was, you know, 15 degrees above normal. And that always helps, I think, frame the firefighter's mind when you're, you know, explaining what the weather is going to be, what the forecast is, to say, hey, and this is, you know, 15, 20 degrees above normals. That helps them frame, you know, what the potential is for the day. Given that climate information, it seems like that is useful.
I think that dovetails next to the next question. Do you look at your real-time information in the context of historic information as a typical part of the forecasting process?
Yep, absolutely. So not only are we looking at it weather-wise, like Patrick said, related to climatology and past weather at that location, but the people we're working with are looking at that as well. A fire behavior analyst, long-term analysts, they're looking at, okay, on these large fire days where we had large growth, what was the weather? So we're all looking at very similar information. Patrick, do you have anything to add to that?
Yeah, that climatology is very important. A lot of that information is referenced, especially like for the RAWS stations, for example. They'll pull that and they'll do a comparison to, you know, to where we're at. Like even with the fuels, we'll say, oh, bad boy, we're as bad as 99, and 99 was a record fire season for that area. You know, that climatology, it does play an important role. And like Kari said, it's not just us looking at it. There's like a little science team, as it were, of long-term analysts, of fire behavior analysts that are all digging into this information and trying to frame our reference for what the potential is and where we're at.
Great, thanks. We have two questions that I'm going to combine here about satellites. Do you use NOAA's polar orbiting satellites to detect hotspots? And if not, or what satellite products do you employ?
Yeah, so a lot of goes west, goes 16, goes 17, a lot of information from there. Definitely, I've been utilizing the polar orbiting satellites more in the last couple of years. That's been very helpful, especially when I was in the North Complex in California. I was using that to get a better zoomed in idea of where the hotspots were, and if it was potentially, the fire was potentially going past the boundaries that we expected it to with a strong wind event. So yes, I have been using it more.
Great. How do you deliver your forecast to other decision makers? Is it an email, in graphics, and how important is it to be on the same map at the same time with everyone?
Go ahead, Patrick.
Okay. We deliver it all. Usually there's one briefing. In a typical fire, you get up, you know, 4 a.m., 5 o'clock in the morning, and you're delivering your briefing either at 5 or 6 a.m., depending on how the team is running things. And that morning briefing is arguably the most important thing you're going to do. And again, just exactly what you said, to make sure that everybody's on the same page, everybody's getting the same information, so that the folks that are out there, the boots on the ground, are able to have the same information and the same background to make the decisions that they need to make that are more tactical in nature out on the fire lines. But even before that, usually late in the afternoon, there'll be a plans meeting, and that's where all the higher ups, the command and general staff, basically all the decision makers from the top to the bottom of the incident will generally be represented in that planning meeting, and that's where the plan for the next day is really shook out, and that's where that information is hammered out. So that's where I guess the sausage is made in some ways. You know, there'll be maybe some discussion or even some debate in those meetings about what the tactics are going to be. But again, making sure that you're consistent is incredibly important, to make sure that your messaging is spot on, and it even goes beyond just what we're messaging. It's very important for us to collaborate with the local folks, the GACs to a certain extent, and the local weather forecast offices and the other IMETs that are around, to make sure that we are both, not both, but we are all on the same page and messaging things in the same way as what the problem is going to be and where the focus needs to be. Because what we don't want out there is confusion. Confusion is really the enemy. We don't want somebody, hearing one thing and trying to take action based on that one thing, and somebody else hearing something else at a different time. It really needs to be uniform and consistent. And of course, there's a typed forecast that is in the incident action plan that everybody will get as well for referencing when they're out and about in the incident. There is a typed forecast in the incident action plan that they can reference, but consistency is very much key to make sure that we're across the board consistent, so there's no confusion.
Yeah, another side of the communication is if there is a thunderstorm that pops up, or we do have a change in the weather forecast, we're actually able to relay that information in real time. Folks do have radios in the field, so we're able to do either weather updates or just emergency notifications to those folks as well, telling them that maybe a thunderstorm is nearby, the potential for some strong winds that could move the fire in erratic different ways depending on the wind direction. It's all about safety.
Great, thank you. We are at our 1 o'clock hour, but I really want to ask, combine two questions and ask it. So if anyone has to jump off, please do. If you can stick around, that would be great. So this last question, are there any tools you wish you had access to while on deployment that you don't today? Or is there any research that you hope was being done that could help you?
Always better internet service. We end up being in remote areas. For me, the incident management teams we're working with, technology has improved so much, but sometimes we are in the middle of nowhere, and it is a little difficult to get very strong internet all the time, but that's okay. One thing we'd always love is more computers, more upper air systems, and just more folks to support the incidents. How about you, Patrick?
It's never been feasible, but it would always be awesome if we could have some kind of a real high resolution, like incredibly high resolution model to be able to run over the terrain, because we are dealing with such complex terrain. That really is one of our biggest challenges. And if we could have, I've seen what some of those high resolution models can do in resolving terrain, and it would be awesome to have that capability out in the field. But honestly, the Larry Van Bussum always says that the hallmark of an IMET is flexibility. He says our saying is semper gumby, always flexible. And so, I guess the thing that I'm used to is just going out and making the most of whatever that I have available. And I think that's one of the keys to an IMET is nothing's ever going to be perfect. Again, the communications is always problematic, it seems like, and time is also always a constraint. But we take the best information that we have available, and we make the best forecast and the best information, the best products that we can to get out there, so that people are making decisions based on the best information.
Thank you both so much. This was great. We did record this, everyone. So if you had to jump off early, or your colleague had to jump off early, please let them know. This will be on the YouTube channel. Thank you so much, Kari and Patrick. This was very good and super enlightening to me, and I hope everyone else. Thank you for joining us. Everyone have a wonderful rest of your day.
Thank you.
Thank you.